This video is on one-step equations. In order to do a one-step equation, you need to do the inverse operation. Inverse operation is just the opposite operation that's shown. So for addition, it's going to be subtraction. So let's go ahead and solve this one. So like the name says, it's just one step. In order to solve this, subtract 3 from both sides. On the left-hand side of the equation, we'll be left with q plus 0, and on the right-hand side, we'll be left with 4. Of course, we're going to simplify this to merely q equals 4. If we're using counters, this is how we would set it up. Remember, this is our variable. For our algebraic lab gear, we're going to call this x, but really we could call it anything we want. So we'll say this is q. Here's plus 3, so I've indicated it with 3 counters, 3 positive counters, and then this line represents the equal sign, and then the 7 counters on the other side. So this is q plus 3 equals 7. To solve this, I've moved my 3 counters from the left-hand side over to the right-hand side. And when I did that, I flipped the counters from yellow to red, because anytime you cross the counter from one side of the sheet to the other side, it's going to flip. So if I moved it from right to left, it would go yellow to red, and the other way it will go red to yellow. Next, I'm going to eliminate the extra counter, so 3 red ones will take out 3 yellow ones. And of course, I'm left with the answer where my variable equals 4. With the algebraic lab gear, this is how I have it set up. Again, here's my variable, plus 3, and then equals 7. Notice I don't use the rounded off rectangles on the top because these represent either subtraction or negative, and I don't have subtraction or negative represented in this equation. So here I've moved my 3 constants up to the right-hand side into my rounded off rectangle because now they are subtraction. So this is a positive 7, this is a negative 3, or it's the same thing as subtracting 3. At this step, I've just traded my 5 rectangle for 5 individual cubes. And then after this, I'll eliminate. So these 3 negative constants will knock out these 3 positive constants. The final answer, of course, will be 4.
All right, for subtraction of integers, you would do the opposite operation, which is addition. Okay, so for g minus 4 equals 10, we're doing the opposite operation, or inverse, which is addition. And I've already set up the problem for you. I've taken 4 and added it to both sides. And then if you notice on the side with the variable g, it cancels out, and so you're left with g, and then 10 plus 4 equals 14. Here is the same example with counters. Remember the blue square represents your variable g, or whatever letter you'd want. Minus 4 equals the 10. And remember with minus 4, it's the red counters, and 10 positive, so we use yellow. So the solution using the counters would be g equals 14. So here's the same example using the algebra lab gear, the g minus 4 equals 10. Here, with subtraction, notice that the negative is up top within the squares on the mat. So what we'll do is, since we're adding, we would move those down to the 5 bars, which makes the 10. So we'll be adding it onto it. So here we've moved them, and you see the answer is 14.
Okay, here we have a multiplication problem, so we're going to need to divide because the inverse operation of multiplication is division. So I'll just divide both sides by 2. Of course, this is going to cancel out the 2 on the left-hand side. I'll be left with just the variable x, and 10 divided by 2 is 5, of course. Here on the mat using the counters, I've represented 2x on the left-hand side and then 10 on the right-hand side. And what I'll need to do is group the counters to the variable. And I've kind of done that already. So here you can see if I just have one variable x, it's going to equal 5. Using the Algebra Lab Gear, I've set up 10 constants within the bar there, and what I'm going to do is I'm going to see how many x's would match up over here when I have 2x. So I'm going to need to set up 2x on that side. Here I have it set up. Now I'm going to simplify my equation. Now we can see that 1x, or x, will equal 5.
Okay, the last example is showing a division equation, so the opposite operation would be to multiply, and here you would just need to multiply 2 times 10. So, which will give you what x is, which is 20. So, in essence, your answer would be x equals 20.
Mm-hmm.